Hello, Key Stage 2. Today we'll be revising electricity. You will learn to set up an electric circuit, recognize the electric current flows, which can be described with models. You will investigate whether an electrical device will be able to work if there is a break or a gap in its circuit. And last but not least, you will recognize how to use electricity safely, which is very important. What is electricity? It is a form of energy. An electric current is the flow of particles carrying that electrical energy around the circuit. And what is an electric circuit? It is made up of different components connected together, forming a path for electric current to flow. A simple electric circuit is made up of the components shown in the table to the right. The first component of an electric circuit is the battery. It is the source of energy in the entire circuit. It has both a negative and a positive end. The wire is the piece that connects all the components together in a circuit. It is made of metal to allow electric current to flow through it. The light bulb lights up when electric current flows through it. It needs to be connected properly in order for electric current to flow. And finally, the fourth component of a simple electric circuit, the switch. It is the piece that controls it all. It's used to open and close a circuit. When the switch is closed, the electric current can flow. But when it is opened, the electric current stops flowing. In this slide, you're looking at all the components and their symbols that make up an electric circuit. The first symbol shown is the 1 battery symbol. And this is the 2 battery symbol used in an electrical circuit model. The wire symbol, an open switch symbol, and a closed switch symbol. And finally, the light bulb symbol that is used in an electric circuit model. And that is all the 6 symbols that you will be seeing in any model made for an electric circuit. And now we are going to talk about all the components of an electric circuit in more detail. The first up is a cell, which is also called a battery. Like we discussed before, it has a positive and negative end on it, as you can see in the picture. Next is the lamp or the light bulb. As you can see in the picture, all the parts that make it up. We have the metal casing, the metal tip, the wires, the filaments, and the glass cover. There are 2 metal wires in a bulb. One is connected to the metal casing and the other one is connected to the metal tip as shown below. For a light bulb to light up, the metal wires must be connected to both ends of a battery. The battery provides energy to push the electric current around the electric circuit. When electric current flows through it, the metal filament becomes very hot and the bulb glows. The battery, the bulb, and wire form a path of electric current flow called an electric circuit. It's like water flowing through a pipe. Now we're going to talk about the closed circuit. A closed circuit is a continuous path through which an electric current flows. It is made up of energy source like a battery and other electrical components such as bulbs and wires, as shown below. Unlike a closed circuit, an open circuit has a gap or a break in it. Hence, no electric current can flow through an open circuit. Look at the picture shown below. As mentioned before, a switch is the piece that controls it all. It is the component used to open or close an electric circuit. If you look at the 2 pictures below, you will see the difference between the open switch and the closed switch. One is a continuous path, which is the closed switch, allowing current to flow through, and the other, the open switch, has a gap or break in it, hence it has an open circuit, and so no current flows through. Furthermore, the table below shows the difference in writing between the open and closed switch. On the left, the open switch has a gap or break in the electric circuit. The electric circuit is now open and so no current is flowing through it. And the light bulb, if connected, will not light up. On the other hand, on the right side, you can see that the closed switch has no gap or break and so it is continuous, allowing for a closed electric circuit and so the electric current flows through. And if a light bulb is connected, it will light up. Now, based on everything that you've learned in the past slides, think about this. When we turn on the switch of a torch or flashlight, the bulb in the flashlight lights up. Why is that? Now that you've had a moment to think about that, I will tell you why. When we turn on the switch, the electric circuit in the flashlight is closed, allowing for a continuous path of electric current to flow through. Hence, the bulb in the flashlight will light up. On the other hand, when the switch is off, there is a gap or break in the electric circuit, and so no current will be flowing. And so the light bulb in the flashlight will stay off. Now we're going to do a quick wrap-up of what you've learned so far in the previous slides. You've learned that a closed circuit is a continuous path through which an electric current flows, and that it's made up of energy source like a battery or a cell and other electrical components such as a light bulb and wires. A battery is the piece essential to provide energy to push electric current around an electric circuit. And we can think of that electric current as particles traveling around the path of an electric circuit. And that an electric circuit can either be closed or open. Electric current can flow through a closed circuit, but it cannot flow through an open circuit because it has a gap or a break in it. And finally, the switch, which is used to open or close an electric circuit. It is in control of everything. In this next section, you will be investigating the 4 factors that affect the electric circuit, which are the type and number of batteries and the type of number of light bulbs. In this next part, we are going to investigate if the number of batteries affects an electric circuit. Apparently, when more batteries are connected one after another in an electric circuit, a large electric current flows through the whole circuit. Hence, the bulbs will glow brighter. On the other hand, if too many batteries are used, too much electric current will flow, causing the metal filament in the bulb to become too hot, and eventually causing the bulb to burn out. But what happens when it's the number of light bulbs that's the changed variable in an electric circuit? Well, when more light bulbs are connected one after another in an electric circuit, a lower electric current flows through it. Therefore, the bulbs will light up dimmer. Look at the diagram below. All right, let's run a quick check. What have you learned so far? Well, we learned that a light bulb's brightness depends on the electrical current flowing through it, and that the larger the electrical current, the brighter the bulbs. And the more batteries connected in an electric circuit, the larger the electric current flowing through it, hence the brighter the bulbs. But if we add more bulbs to the electric circuit, the electric current will be lower, hence the bulbs will be dimmer. Most importantly, you have to remember when carrying out an investigation, you need to change one variable at a time. The variables are as follows: number and type of batteries, or number and type of light bulbs. Remember, only choose one. And we have come to our final part of this lesson: how to use electricity safely. Electricity can be very dangerous if not handled carefully. We all know that, right? It can even cause fires and electric shocks. Ooh. Here are some ways to use it safely. Don't connect too many plugs to one socket. Turn off switch before removing a plug. Don't ever touch a switch or device with wet hands. And don't use or touch exposed electrical wires. Duh. Now that you've all become geniuses on electricity, how about you take a moment to test yourself? Grab a pen or pencil and paper and answer the questions on the next few slides. Ready, set, and go. Now you should all have a pen or pencil and a paper. You don't need to write anything except for a brief answer for each question. Ready? I will read them to you. A. Which variable was changed? Look at electric circuit A and look at electric circuit B and figure out which variable was changed. Number B. Which variables were kept the same? Write down 3. Remember the 4 variables that we've discussed previously. Number C. Tim observed the brightness of the bulbs in both electric circuits. What was he investigating? And last, number D, which bulbs will be brighter? The ones in electric circuit A or B? Why do you think so? And here's the answer reveal. The answers are as follows. Number A, the number of batteries. Number B, the number and type of light bulbs and the type of batteries. Number C, Tim was investigating how the number of batteries affects the brightness of the light bulbs. And finally, number D, electric circuit A, because it has more batteries providing more energy for the current flow to be pushed around the electric circuit and lighting up the light bulbs stronger. Check your answers, and I really hope you got them all correct. Okay, moving on. Study the circuit shown and think about what happens to the bulbs as the switch is closed and when it is open. Now pause the video for a little bit, give yourself time to answer it, and the answer is revealed in the next part. Okay, so in the table underneath the question that you were just answering, you will see that a switch, when closed, the electric circuit will be also closed, and so the electric current will flow through it and bulbs will light up. But on the contrary, when it is opened, there will be a gap or break causing the electric circuit to be open with no flow, and bulbs will stay off. All right, we're going to continue practicing. And just like we did previously, you're going to look at the questions and pause the video. Use your pen, pencil, and paper to write your answers. Play the video and check. Okay, I am going to now read the questions to you. Study the electric circuits on the left, circuit A, B, and C. Number 1, investigate whether the number of bulbs affects the electric current in an electric circuit. A, which variable must you change? And the number of bulbs is correct. Okay, number B, which variables must you keep the same? Can you write down 3? Impressive. It is the type of bulbs, the number, and type of batteries. Correct. Now, moving on to the last question, number C. Which 2 electric circuits should be set up for this investigation? Think before you answer. If you have answered circuits B and C, you are correct. Now you have completed your first official investigation. Moving on to the next. Okay, you're going to be looking at the same 3 circuits listed on the left side, A, B, and C, but this time you're going to investigate whether the number of batteries affects the electric current in an electric circuit. Number A, which variable must you change? You are on a roll. Yes, the number of batteries is correct. Number B, which variables must you keep the same? Can you please write down 3? Okay, it is the type of batteries, the number, and type of bulbs. Correct. Number C, which 2 electric circuits should be set up for this investigation? Think before you answer. And you should give yourself a pat on the back. You just completed your second investigation. If you answered circuits A and C for number C, you're right. This diagram here is going to summarize everything that you've learned so far about an electric circuit. It is, follow along the green arrows, please, the path through which an electrical current flows and is made up of electrical components, such as a cell or battery that provides energy to push the electric current around the electric circuit, a switch that closes or opens the electric circuit, and a bulb which lights up when electric current flows. And finally, no, I mean it this time, guys, really, finally, follow the blue arrows, please. An electric circuit, when closed, has an electric current, and when open, doesn't have an electric current, which is affected by the number and type of batteries and bulbs in the electric circuit. Okay, KS2, now that you've learned everything you need to know about electricity, It's time to say, till we meet again, take care.